So in this question, we have a position time graph. We'll begin with our Oizerga. Our origin's in a good spot. It's right there at the quadrant 1. Our y-axis is position in meters, time in seconds, so we'll read position in time. The gradient's delta x over delta t, which is the average velocity, and the area is xt, meter seconds, which has no value whatsoever. We now look at this question. 2 identical carts, and why identical carts are important is that tells us that the masses are equal. Straight track is a function of time. The magnitude of the momentum of the system, center of mass, PCO of mass is true. So what is happening to the momentum of the 2 carts system of the center of mass? So let's first figure out this center of mass, and let's start in the beginning. And this is the best place to always start, at time 0. At time 0, these carts are identical. They're in those 2 locations. That's the center of mass. We go to the end of that period of 2 seconds, and the center of mass is here. So that means that this is the graph of the center of mass. Now, if it had continued onward, the center of mass graph would look like that. It would be a straight line. Because the slope is the velocity, the mass is, if the momentum is mass times velocity, the mass remains the same. And if the velocity remained the same, the momentum, if the velocity remained the same, momentum would be the same. But we can see there is this deviation from point 2. So that's what it would look like if it were the same. Okay? Now, if we now go to afterward, cart 1 is located here, cart 2 is located there. And the center of mass of these 2 identical carts would be in the very middle, which is right there. So the curve would look like this afterward. And so we can see the V is less, and P equals mv. The mass is the same, the V is less, so the momentum is less after 2 seconds. So now let's see. Center of mass is constant from 0 to 5. Well, we know it's not. The green line deviates, so that's out. Center mass is smaller at t equals 2 than it is before t equals 2 seconds. And that seems to be true. So we think that's our answer, but of course we are not going to settle for that. It's larger afterward. No, that means it would have needed a steeper slope. That can't be true. It increases a constant rate from 0 to 5 seconds. Well, if it increased at a constant rate, then for the momentum to increase, we have the same equal mass, the velocity would have to increase. And we can see that the velocity, which is the slope, does not increase at all from 0 to 2, so this one is false. So we've not only falsified all the wrong answers, we've demonstrated why the B is the correct answer.